Now, when it comes to microcontrollers, proprietary cores have fallen largely out of favor and been replaced by technology from ARM. And we're here today to find out how ARM are supporting the semiconductor vendors bringing their microcontrollers to market faster through virtual hardware prototyping and support, and also supporting machine learning and neural networks to get them to market faster. So hi Mohamed, it's great to see you back here at Embedded World 2022. It's obviously been a couple of years of pause. We're here to find out a little bit more about what ARM's been doing and creatively in the background.
Yeah, absolutely. No, thank you. It's great to be here. You know, the quality of the conversations and stuff have just been fantastic, and I think a lot of it has to do with just the sheer energy. You know, everyone just getting to touch hardware and see things in real life has been fantastic.
Exactly. Now, when we go to the ARM website, one of the things that pops out prominently is total solutions for IoT. So how is that? What does that mean to you and to the partners that you work with in the semiconductor vendors?
Yeah, I mean, ARM Total Solutions is an initiative that we launched about 9 months ago now, and it's really all about accelerating the time to value for the entire ecosystem, whether it be semiconductor partners, software providers, all the way through to ISVs and those that deploy technology. It's really 3 components to it. The first component are pre-integrated, pre-verified compute subsystems. So these are, we take our IP, we bundle them up, we target a specific use case, and we make that verified, integrated IP available to our semiconductor partners so that they can quickly take it, add whatever differentiation they want, and tape out. It accelerates their time to revenue quite substantially. The second part of it is we take those reference designs and we make a virtual model of it available in the cloud. So that at the same time we release the hardware or the IP, we release this virtual model. That ARM virtual hardware is then available for software developers to go online and start writing software for IP as soon as we release it. It also enables things like CI/CD. And the final part to ARM Total Solutions are our packages like like Project Centauri and Project Cassini. They're all about putting the right standards in place and enabling the software ecosystem with the right reference software and implementation software to enable secure deployments across the broad ecosystem. Project Centauri and Project Cassini are all about enabling software leverage.
Now, obviously, the semiconductor vendors can benefit from this greatly as they're trying to innovate and create with new technologies and try things out. Are they passing on that virtualized hardware platform to their customers as well to start developing before the chip arrives?
Yeah. So when we talk about ARM virtual hardware, we actually put it right up in the cloud and we deliver it directly to the software developers. So we make it available. At the same time, we make the IP available to the semiconductor guys. We make the virtual models available to the broad ecosystem. So software developers can literally start developing from the convenience of their homes without having to worry about wires and jumpers and cables or the availability of silicon.
Or even if it's plugged in.
Yeah,
that's
exactly,
another challenge.
Exactly.
Now the Corestone 300, that's got a Cortex processor integrated into it, but one of the interesting elements of that platform is also the neural processing unit, and that I think reflects the growth in machine learning. How are you tackling machine learning at ARM and that growth in interest?
Yeah, it's really interesting. So if you think about machine learning, I would venture to guess that more machine learning runs on ARM processors than anything else, just starting with the Cortex-M family. Over 225 billion ARM processors out there in the world. To talk about machine learning specifically, we actually have 2 recent Corestone designs which we've released, which feature machine learning pretty heavily. One is the Corestone 300 that you pointed out. It's got a Cortex M55 and then our Ethos U55 NPU on it. And then we also have a Corestone 310, which has our newest, fastest, most secure Cortex ever, the M85, along with the U55. What we do here is in both of those cases, whether it's the Cortex M55 or the Cortex M85, actually have machine learning acceleration built right into the CPU core. But beyond that, we've actually added the optional U55 next to it for those next level applications that need a massive amount of. What you're seeing across the board in all of our solutions, in all of our offerings, is that we're providing the right tools so that people can customize a solution for the particular use case. And that's so important and frankly what separates ARM.
Now, security is obviously a big concern, and putting stuff in the cloud, some people are a bit reticent to do that. So with these cloud platforms, how can the semiconductor vendors and the other users be sure that nobody's able to look at what everyone else is doing?
Yeah, I mean, so obviously we have on-prem offerings as well if people are worried about it, but security in the cloud is really second to none. If you look at what the cloud providers have done, they take a lot of care to specifically go off and ensure that there's a level of security in their cloud-based services. For some people, that's not going to be the right thing, and they might want to go on-prem.
We also saw a bit about Project Centauri on the website. Could you give us a bit more background on what's going on there?
Yeah, Project Centauri is looking to do for M-class devices what Project Cassini does for A-class devices. So specifically, it's there to enable software leverage. So, there are certain attributes of M-class devices in IoT in IoT devices which are common across everything. So the example I like to give is over-the-air updates or software updates. Every IoT device needs to support software updates, and they need to do it securely. There's plenty of room to differentiate on how it's actually done, whether you're going to go over a wireless link or a wired link, how you're going to secure the device, but there's no argument about whether it needs to happen. So one of the things that Project Centauri looks to do is standardize how software could go off and invoke that service on the device. There's no reason for that to be different across devices. That just creates frustration for software developers and slows down, how much they can innovate.
Exactly. So it's a very interesting time at the moment also with, as we said before, machine learning, artificial intelligence. What's surprising you about the embedded industry and how they're approaching machine learning at the edge?
I think what's interesting to me is how quickly they are and how much interest there is in machine learning. I mean, machine learning is obviously been around for a little bit, but it's really in the last couple of years there's been this massive swell of interest. We're seeing it across the board, and it's really being adopted in all sorts of interesting use cases. So I think what will be interesting to see is how the ecosystem evolves to actually go off and transform itself from the sort of classic development environments where machine learning and dealing with models in that sort of abstracted way, how that melds with embedded software design. I think the intersection of those two things is going to be fascinating. And for our part of what we're doing around Project Centauri and ARM virtual hardware is really specifically targeted at enabling that type of development. I'll give you a quick example. Like if you think about ML developers, oftentimes ML developers and data scientists, they're not the same people as embedded developers.
Exactly, yeah.
Very different development flows. ARM Virtual Hardware was originally targeted specifically at ML developers. It was there so that folks could go off and quickly in the cloud go off and test their models, test the functionality. In fact, some of our earliest users of ARM Virtual Hardware are companies like Amazon, who are using it for Alexa wake word testing, all the way through to Google, who are using it to validate TensorFlow.
Super. Well, thanks very much. It's great to see you back here at the Embedded World Show. I hope you are gaining as much out of this experience as I am after a 2-year pause. And we wish you all success and look forward to seeing what comes next from ARM.
Thanks so much. It was great to talk to you.